Here we're looking at example 5 from our 2.7 set of notes. Now we're asked to graph this absolute value function and find these different items to help us out. So our vertex just comes out to be the opposite of this guy for our x value. And this one we're just going to take him just as he is, even with that negative. And that would be our y value. So our vertex then is happening at -3, -6. So -3, -6 is right here. Just from our value in front of that absolute value, we notice it's 3 halves. It is positive, so this thing should be opening upwards. Now going ahead and looking for our x-intercepts. Well, if we're trying to cross this x-axis, finding that x-intercept, notice that the y values are not going to be going up or down any. That's why it's going to be 0. So we're going to go ahead and let y be 0. So 0 is equal to 3 halves times the absolute value of x plus 4. I'm sorry, x plus 3 minus 6. And now we're just trying to solve for this x variable. So we're going to add 6 to both sides. End up with 6 is equal to 3 halves times the absolute value of x plus 3. Multiplying both sides by this reciprocal, we end up then with, so we're going to multiply this by 2/3 on both sides, because then these guys would end up canceling on the right side, leaving us our absolute value all by himself. On the left, we have 2 times 6 is 12, divided by 3 gives us 4. Another way you could do it is that shortcut where 3 goes into 6 twice. 2 times 2 is 4. Now that our absolute value is all by himself equals some number, notice this number is positive, so we can actually go ahead and do our split, where we have x plus 3 is equal to positive 4, and x plus 3 is equal to negative 4. And then just solving for x. So we end up then with x is equal to 1, and x is equal to -7. So it looks like our intercepts, our x-intercepts, are happening at 1, 0 and -7, 0. So graphically, those are right here and right here. Now going ahead and trying to find out what is that y-intercept. Well, we pretty much just do the exact same thing, but if we're looking to see where is it crossing this y-axis, our x variable is not moving left or right any, which is why he's going to be 0. So we can go ahead then and throw in 0 for x. We then end up with y is equal to 3 halves times the absolute value of 0 plus 3 minus 6. And now it's pretty much just simplifying things on the right side. So we end up with 3 halves times 0 plus 3 is 3 minus 6. Absolute value of 3 is 3. Three halves times 3 comes out to be 9 halves minus 6. And there's a couple ways you can continue on. You could convert this to a proper fraction, or you could do a little bit of FFU. I think we'll do the FFU so you guys can get more exposure to that. So we want this to have the exact same bottom. Right now it's 6/1. We want this to have the same bottom such then that we can go ahead and combine the tops. So we're going to do FFU by multiplying this by 2/2. Then they would have the same bottoms. So then we would end up with 9 halves minus 6 times 2 is 12 over 1 times 2 is 2. Again, right here with that FFU move, you're not actually changing this guy. You're just changing the way he's looking is all. Because 12 divided by 2 is still 6. Okay, so just changing the way he looks such then that we can go ahead and combine our tops. Now the bottoms are matching. 9 minus 12 gives us -3 over 2. So it looks like our y-intercept is happening at 0, -3 halves. So -1 1/2. Graphically, that should be right here. Now again, with the vertex, what that does is creates that axis of symmetry, which is essentially that mirror that we've been seeing. So the left side should mirror the right side. And, well, we can see that we already have the mirrors of these 2 points becoming from our x-intercepts. But we have this other point here from our y-intercept. So let's go ahead and mirror him. We notice that he is 3 from our mirror on the right side, so we'd have to go 3 to the left of our mirror. And so we'd end up with another point, looks like -6, -1 1/2 for that mirror. And pretty much all you have to do now is connect all the points together. So you should see an absolute value function graph looking something like that. Again, that is example 5 from our 2.7 set of notes.